So we're continuing the videos on atomic structure, and we're now going to look at those three forms of ionizing radiation, starting with alpha particles. Introducing the alpha particle then. When a particularly large nucleus is of a certain size, it can give out, literally just emit, 2 protons and 2 neutrons, or a helium nuclei, and you can use either to describe what an alpha particle is. An alpha particle is either 2 protons and 2 neutrons, or a helium nuclei. The process of it giving those out means that the mass number has decreased by 4 and the atomic number has decreased by 2. That means the atom has changed. It is no longer whatever the unstable element was in the first place. It is now a new, different element because the atomic number has decreased by 2. The alpha particle itself is going to have a charge of +2 because there's 2 protons in there. So this is an example of the decay. It's what we call the decay equation, and you need to be able to construct these and make sure that they're right or correct. Explaining this nuclear equation then. I've got an example here of an alpha decay, where an isotope with an atomic number of 95 and an atomic mass of 241 decays via alpha decay into an isotope with an atomic number of 93 and an atomic mass of 237. The key thing to appreciate about all nuclear equations is that they are just that, they're an equation, which means that the total mass numbers must balance. The total numbers across the top of each of the symbols must balance. So in this case, 241 must equal 237 plus 4. And on top of that, the total atomic numbers must balance. So the 95 must equal 93 plus 2. All the nuclear equations that we ever deal with, and when we're talking about either alpha or beta decay, obey those two rules. So if ever you're asked to complete one of these, like fill in the missing numbers, just check the simple math equation to make sure that those numbers balance out accordingly. You need to know the properties of an alpha particle. Now I've left on the top right corner of this the two different potential symbols that you may see for an alpha particle, because it is fundamentally a helium ion. It is a helium 2 plus ion where it's lost both of its electrons. So you can either see the alpha symbol or helium in that space in the middle. Key things you need to know about it are this. Mass. It's the heaviest of the ionizing radiations. It's got an atomic mass of 4 AMU, which is tiny in terms of kilograms, but it is the heaviest of these three types of ionizing radiation that you need to know. Penetration. What can it get through? Alpha particles are easily stopped. They are big, and the properties that they have mean that they can only travel a few centimeters in air, and they're easily stopped by paper or even skin. Like literally the top layer of skin is enough to stop the alpha particles. Ionization, which is how good they are at extracting these electrons from other atoms. They're the most ionizing type of radiation. This is a combination of their large positive charge and the highly chances of them colliding with other atoms means that they are most likely to cause other elements to lose electrons as the alpha particle removes them from there. Speed, they're the slowest. They're the biggest. They're the slowest of the ionizing radiations. You just need to have good awareness of that one. You also need to know about what happens when they go in a magnetic field. Now, the combination of the mass of the alpha particle and the fact it has a charge, a +2 charge, means it will gradually change direction in a magnetic field. By gradually I mean that typically if you've got a choice of a very rapid curve or a gentle one, the more gentle of the two curves will typically be the alpha particle. You need to be able to describe a use for alpha particles. Now the main use that you need to be aware of is smoke detectors. So all of you should in theory have some kind of alpha source in your home. A lot of smoke detectors use this. It's one of the simplest methods of doing this task. Alpha particles ionize air. So if you can put them into a situation where there's a gap, you can allow current to flow through the air in that certain gap. So there is the alpha particles going into the gap and it's causing charged ions to move between the two. And as long as there's a current flowing, the alarm won't sound. Smoke getting into that gap stops the current from flowing. Effectively, the smoke particles prevent the charged ions from moving between the two plates. When the detector picks up that there's no current, it sets off the alarm, sounding a siren or a sound of some form in order to let you know as an individual that there is some smoke in and around wherever your smoke detector is. The reason why, if you can sometimes kind of blow on or kind of get airflow through a smoke detector it switches off, is because you're clearing the smoke from inside that gap. Key things you need to remember about alpha particles and alpha ionizing radiation. An alpha particle is 2 protons and 2 neutrons escaping from a large unstable nuclei. And the other way that you can always refer to this is as a helium nuclei. In an exam, either is considered acceptable, either saying 2 protons and 2 neutrons or saying a helium nuclei. After the decay, the nuclei that you started with, the unstable nuclei's mass number decreases by 4 and the atomic number decreases by 2. So you end up with a new element. It has the greatest mass of all the ionizing radiations. It's got the slowest speed. It's the least penetrating, stopped by either paper or a few centimeters of air. It's the most ionizing. This combination of its charge and its size means it's most likely to interact with other atoms and remove electrons. It's deflected by a magnetic field, but its mass means that it's not deflected very quickly by that field. Alpha sources are used in smoke detectors because they can ionize the air, allowing charges to flow, and when smoke gets in the way, that stops the charge flowing, and that's detected by the alarm and sets it off.